Okay, future engineers, let's proceed with our next problem on free vibration response. So we have here a helical spring of stiffness K is cut in two halves and a mass M is connected to the two halves as shown in figure A. So ingon niya, so kaning first statement para mas masabtan nato ato ning putog tagsa-tagsaon og sabot. Ingon niya naay usa ka spring and then katong usa ka spring gitunga daw. So ang usa ka spring iyang stiffness is K. So first naa siya usa ka spring. Sa diya kay murag lain. Okay? So naday usa ka box spring. So iyang stiffness is K. Of course, iyang length is represented by L. Next, ingon niya gitunga daw ni into 2. Tapos gi-connect siya sa usa ka mass M. So mo siya si figure A. So na kay mass M and then katong gitunga nimo gi-connect nimo siya in parallel connection ni mass M on the left and on the right. So mo siya 1/2 of the length or L over 2 and L over 2. Next. So next nga problem. Statement rather. The natural time period of the system is found to be 0.5 seconds. So ang natural period daw is found to be 0.5 seconds. So let's say this is the first condition. This is the natural period. So we have this is the natural period of TA or of the first system. Well, let's say this is T1 is equal to 0.5 seconds. So if you remember, no, the natural period is the the time taken to complete a cycle. Next, the third statement here we have if an identical spring, okay. So same spring down with stiffness K and then is cut so that 1/4 and the other 3/4 of the original length and the mass M is connected to the parts as shown in B. So mo siya same nga spring gitunga siya pero 1/4 ug 3/4 dili na 1/2 and 1/2. So we have here L over 4, 1/4 and 3/4. 3L over 4. Gi-connect yapon siya sa ato ang mass M here. Sa may problema niya gipangita, what would be the natural period of the system? So pangutanan niya, what is the natural period of this system? Okay. Naunsaon na nato. So mo to siya no? Okay, we have already identified that this is in parallel connection. Next. So dagan mo tag formula no, we have the natay katong omega is equal to K over M. Our period is equal to sa to? That is 2 pi over omega. Diba? And then we can substitute omega here. Then na po take K. No? At we take into consideration the stiffness of the springs here. So may first na to buhaton. So pangitaan na to og stiffness ni kaninga part. So first so sa katlo siyang spring na siya stiffness K. Gitunga man siya, of course, mula gid ang stiffness. So inyo, if you remember no, itong general formula nato sa bending stiffness or actual stiffness lugar, we have the EA over L. FCL magkagamay sa metabo ni stiffness magkadako, di ba? So if you have EA over 2 and then you have EA over 1 or EA just EA and then EA over 0.5. So if you notice nga if ang length is magkagamay, the stiffness will magkadako. So let's try to kuan. So that is the relationship of the stiffness when it with respect to the length. So first na to button is pangita na to og stiffness. Unsa man ni siya? Let's say our stiffness here is K1. Since same man sila og length on the other side, stiffness also here is in K1. So since this is in parallel since that is in parallel, diba, we can just add K1. So our K equivalent is equal K equivalent 1 for this condition is just equal to K1 plus K1 or equal to 2K1. But pangitaan sa nato og relationship si K1 ug kani si K. So kani sila nga system ang kaning gipangbungkag nato nga spring ato ni silang i-relate no sa original stiffness and sa original nga length. So sa may relationship ni K1 with the original stiffness. So we have 1 over K total is equal to 1 over K1 plus 1 over K1. So K1 o K1 lang yapon because same mo sila stiffness. So ang first nga 1 over K, so ang K total na to is the K, the original one. We have so 1 over K1 plus 1 over K1. Same denominator that will result to 2 over K1. Or if you cross that one, you can get that K1 is equal to 2K. Now if you substitute that here, you will get that the K equivalent 1 for our first system or the equivalent stiffness for our first system is just equal to 2K1 or 2 times 2K or 4 times the original stiffness. So if yun man matigdan, no? Diba? Pag magkagamay select, magkadako ang iyang stiffness. So the equivalent stiffness ani na nga system ni kanini figure A is equal to 4 times the original stiffness. So after getting the stiffness, sa may nasa to buhaton? Natay given nga T1. So ato na gamiton si T1. T1 is equal to 0.5 seconds. And then the formula is equal to, unsa ganito? 2 pi over omega or 2 pi over square root of K over M. So kana si kuan 2 pi over square root of K over M, pwede na nato na masulat into 2 pi square root of M over K. But for the first system, this is the equivalent stiffness 1. Okay. So we will have 0.5 seconds is equal to 2 pi square root of mass over 4K. Or since C4K, that we know that the square root of 4 is 2, we will have 0.5 is equal to 2 pi over 2 square root of M over K. Or simply, napatras na tayo. We have 0.5 is equal to pi square root of M over K. We know that square root of M over K is just equal to 1 over omega. Or simply our natural frequency is just equal to pi over 0.5, or the natural frequency of the first system is equal to 2 pi. Okay, next. Saan natin buhaton? So, take note we just rewrite that here. We have the answer to omega 1 is equal to 2 pi, or 1 over omega 1 is equal to 1 over 2 pi. So, mo ni siya katong si square root of M over K. So next, sa buhaton na to, we have to consider na dayon this one. So we have L over 4 and 3L over 4. So mo to siya, since pangitaan na po na to og, so kung kani siya, we have the K1 here, is equal to K1. So dili, ibutan na to, this is K2 and then this is K3. So pangitaan na to ni si K2 or si K3 og equivalent stiffness sa original. So saan mo na to da? So if you remember that the force is equal to Kx, diba? Spring force. Then we have that the stiffness is equal to F over X. And then, if you remember, no, that stress, sigma is equal to force over area. Then, the modulus of elasticity is equal to stress over strain. Now, if you cross this strain on the other side, you will have that the stress is also equal to the modulus of elasticity times the strain. So, if you equate this to equation, you will have modulus of elasticity times the strain is equal to the force over area. Or, you will have that the force is equal to, the spring force is equal to E A strain. The modulus of elasticity times the area times the strain. And then if you substitute the value of the strain, you will have EA times what? We have the deformation delta over the total length. Or EA delta over L. Again, let's recall that the K is equal to force over the deformation delta. So, si delta, so there we have X. Actually, pwede na siya si delta or this delta. So, this denotes deformation or katong ginagamit nato before, we have the U or the U of T. Diba? For dynamic force. So, we have, since F is equal, since the stiffness is equal to force over the delta or the deformation, so natay stiffness is equal to EA over L. Okay, so taas kayo no. So we try to relate the original stiffness with this stiffness. So we have K2 over K is equal to EA over L. Now, atong L for K2 is this one. This is the L over 4. So we have L over 4 over the original spring, we have the EA over L. So yung original length is L. And then si K2, yung length is just the L over 4. That's why we have here the L over 4. Yung anong same naman sila E o A? It is because they are same material. Therefore, the modulus of elasticity and their cross-sectional area is just also the same. Now, if we simplify that one, we have K2 over K is equal to, we have the numerator times the reciprocal of the denominator. So, we have EA. So, we have here the numerator at times the reciprocal of the denominator. Here, we have that becomes 4 over L. And then, this numerator times the reciprocal of this denominator, we will have L over EA. Diba? So, the EA, makancel lang. The length is also makancel. So, we have the ratio of the stiffness K2 over the original stiffness K is equal to 4. Or K2 is equal to 4K. Actually, katong first one, ingani na gaya pa ng pamaging gibuhat na to, no? That K1 is equal to 2K. Since K2 is equal to 4K, so may next na ito buhaton. Pangitaan na po din nato si K3. Sa same yapon nga pamaagi, no? Like this one, we have the K2 of K3 rather over K is equal to EA over 3/4 L over EA over L. We will arrive that the K3 is equal to 4 over 3K. So this is the relationship of K3 with the original stiffness K. So we already have K2. We have K3. Unsa yung next buhaton? Find the equivalent stiffness. So that is just equal to K2 plus K3, which is equal to 4K plus 4 over 3K. So, kung makita nung magkadagamay ang length, magkadako po si stiffness. For the equivalent stiffness, okay, for the system 2, that is just equal to 4 plus 4K plus 4 over 3K. That is equal to 16 over 3K. Next, sa ibuhaton. So we have, diba, we try to get again the time period of this one. We have the T2 is equal to 2 pi over omega, or 2 pi is times the square root of m over k, equivalent to. So we just substitute that one. We have the T2 is equal to 2 pi square root of m over 16 over 3k. So atong ginapangita og so si K equivalent ato ginarelate into K para nata relationship ni system A og ni system B. So we have T2 is equal to, we have the square root of 2 square root of 3 pi over 4 square root of m over k. Simplify lang na to. We have the T2 is equal to pi over 3 pi, square root of 3 pi over 2, square root of m over k. So if inyo nadumduman nga the square root of m over k is just equal to 1 over 2 pi. This was solved earlier. So, if you substitute that one with T2, we will have T2 is equal to square root of 3 pi over 2 times 1 over 2 pi. So, makasa si pi. Then, the natural period of the new system is just equal to pi over 3, square root of 3 over 4 seconds, or simply 0.433 seconds. So this is the period of the new system. So mas gamay yung period, no? It takes 0.433 seconds to complete a single cycle in this system.